Hey everyone, so we'll be exploring blood today. It's chapter 17.1 and 17.2, so we're just going to be overviewing it today, and it will be overviewing what it is and its components. So let's start. What is blood? Blood is a connective tissue, but it doesn't have the regular connective tissue stuff like proteoglycans and whatnot in its extracellular matrix, but it has proteins seen as fibrin during clots. And it's different because it's a liquid connective tissue, and it's the only liquid connective tissue. When spun in a centrifuge, which is a circular device, and it has tubes attached to it, and it spins rapidly, so it can separate the substances within those tubes from highest mass on the bottom and lowest mass on the top of the tubes. So from lowest mass to highest mass, there's plasma in your blood. It's a straw-colored fluid. It's 90% water and 8% proteins. There's a buffy coat, which is made up of platelets and white blood cells. And then there's erythrocytes, red blood cells. Now take a look at this picture of a tube of blood. There's plasma, makes 55%, buffy coat makes less than 1%, and erythrocytes makes around 45%. It can vary, but this is on average. And the percentage of erythrocytes in your blood is called the hematocrit. Now, here are the physical characteristics. It's a somewhat sticky, opaque fluid. It has a metallic taste. It can be bright scarlet when there's oxygen in it, and it can be dark red when there's no oxygen in it. It's somewhat alkaline, so remember your pH scale. If it's below 7, it's acidic. If it's above 7, it is alkaline or basic. So its pH is around 7.35 to 7.45. The temperature is around 38 degrees Celsius, which is around normal, but it can go a little higher because it absorbs heat. And it's around 8% of your body weight, and the average volume is 5 to 6 liters in males and 4 to 5 liters in women. So the liter is basically a cube decimeter. So remember, a decimeter is 10 centimeters. Now here are the functions. So it distributes, regulates, and protects. It distributes oxygen to your tissues and wastes and hormones and such and such. So it's good for transportation and distribution. It regulates, so it involves maintaining temperature through distribution and absorption of heat. It maintains pH through different solutes and bicarbonate atoms, and it maintains volume through salts. And it also protects, so that involves prevention of blood loss through clotting and prevention of disease and infection through white blood cells. And we'll talk about their components next. So let's talk about red blood cells. So your red blood cells are also called erythrocytes, as I said before. They're flat and biconcave, which means they're a little bit donut-shaped. They're pretty much bags of hemoglobin since they have nothing in them besides hemoglobin. They have no organelles whatsoever. Their function is to exchange respiratory gases, so carbon dioxide and oxygen. We use your red blood cells to figure out your blood type. They form by erythropoiesis, and the protein that regulates this is called erythroprotein. Now, the lifespan of your red blood cells is around 100 to 120 days, and its death is called apoptosis, and apoptosis is caused by changes within the plasma membrane of your cell that allow white blood cells to detect it and phagocytose it. Now, here's a hemoglobin molecule. It's made up of alpha helix proteins and beta pleated proteins, and it's made up of a protein called globin. And if you don't know what alpha helix and beta pleated is, you're going to have to check chapter 3 again. And it also has chemical compounds on it called heme groups. And those heme groups are where oxygen attaches to, and the proteins are where carbon dioxide attaches to. Now here's a little diagram of blood types. So there's O, A, B, and AB. And the type depends on the antigens on your blood. So O has no antigens, A has an A antigen, B has a B antigen, and AB has both. Now there's also another antigen that could make your blood positive or negative, and that is the rhesus antigen. So if you have a rhesus antigen, you're positive. If you don't, you're negative. And O can give to A, AB, and B, making it the universal donor. AB can receive from all of them. But you also have to think about it, another factor, though. So if you have an antigen that was that is newly introduced into your blood that is not an antigen that has been seen before in your body, then that your body will react negatively to that. So if you put B blood into someone with an A blood, then their body will react negatively to that because they don't have B antigens in their blood. So technically, if you are an O negative, you are the universal donor, and if you are AB positive, you are the universal receiver. Now here's a few pictures of red blood cells. Your chapter doesn't really go over hypertonic, isotonic, and hypotonic, but chapter 3 does. But this chapter doesn't. But anyway, I just wanted to show you a picture of red blood cells, and they're flattened by concave, donut shape. This is a healthy blood cell. I talked about hypertonic and hypotonic in chapter 3, so you can review that again. So let's go to white blood cells. They're also called leukocytes. There are two types, agranulocytes and granulocytes. Granulocytes consist of neutrophils, which are bacteria fighters, basophils, which secrete secrete chemicals that allow allergies and antigens to respond to pathogens, and eosinophils, which are parasite fighters. Now, onto your agranulocytes, there are monocytes and lymphocytes. So monocytes don't really do much, but they do present stuff to T cells, and they'll eventually turn into things called macrophages, which are white blood cells in any other tissue besides blood. And then there are lymphocytes, which can be divided into B cells, helper T cells, and cytotoxic T cells. B cells, to put simply, they release antibodies. Helper T cells, to put simply, coordinate the pathogen eating, and the cytotoxic T cells destroy the pathogens. So here are your leukocytes. And I just want to mention that agranulocytes have no granules in them, and granulocytes do, as you can see right here. So here's a macrophage, there's a macrophage, and it has no granules. There's a lymphocyte, it has no granules. But neutrophils, eosinophils, and basophils have granules. They didn't draw them with granules here, and I don't know why, but they do have granules. Anyway, here are your platelets. They're also called thrombocytes. They're responsible for clotting. They release chemicals that help with aggregation, which is the attraction of other platelets to a specific area. Vasoconstriction, which is making your blood vessel smaller. And coagulation, which is another word for clotting. So the chemicals that do this respectively are called thromboxane A, serotonin, and thromboplastin. They release a bunch of healing growth factors as well. Two examples would be platelet-derived growth factor and TGF-beta. These have been seen to help with regeneration of connective tissue as well. Now let's go to the formation. So they come from hematopoietic stem cells, and hematopoiesis is a general term for blood cell formation. And hematopoiesis occurs usually in your blood marrow or bone marrow, red bone marrow, but it can also occur in your spleen, liver. When you're a baby, when you're an embryo, it occurs in areas called blood islands. But as you develop, your spleen and your thyroid and stuff, they start making blood cells. And then when your bone marrow develops, that's when your bone marrow takes over and does all the rest of the blood cell formation. The end results of these formations can be divided into erythroids, lymphocytes, or myelocytes. Now, lymphocytes here are different in concept from the past lymphocytes because this just describes the evolution of the cell into its final product, which can be erythrocytes, thrombocytes, white blood cells. So here's a little diagram of hematopoiesis in humans. So as you can see, there's a hematopoietic stem cell, also called a hemocytoblast. It can divide into something called a myeloid progenitor or a lymphoid progenitor, or it can just divide back into a hematopoietic stem cell. So depending on the cell evolution, it can be divided into erythroids, lymphocytes, or myelocytes. Myelocytes are anything from a myeloid progenitor besides erythrocytes, and erythroids are anything that comes from this lineage to an erythrocyte. Now, lymphocytes come from a lymphoid progenitor. So as you can see right here. I'll put a picture of, or I'll put this picture, the link to this picture below because it comes from Wikibooks. Anyway, so thank you for watching, and we are done. See you next time.